Okay, so our goal today is to be able to identify and write ratios. We're going to finish that up. And then we're going to be focusing on writing ratios as fractions. That's one of the three ways to write them, but we're really going to focus on the fraction part today. So I believe yesterday, did we get to drawing the model at the bottom? Okay, and we talked about part to part, or did we not talk about part to part? Okay, a little bit. Perfect. So, if you haven't drawn the bracelet above the hole-to-hole in this area right here, please do that now. So I think we got to yesterday. So, what is a part-to-part ratio? Using that bracelet, what do you think a part-to-part ratio would look like? So it's a comparison of two numbers, a part to a part. Right? 4 to 3. 4 what?
4 little beads.
Perfect. 4 little beads to 3 big beads. So you can go ahead and draw this here, these models that represent the ratios. 4 small beads to 3 big beads, or you can do 3 big beads to 4 small beads. Okay, you're comparing two separate things when you have a part-to-a-part ratio. Next one is part-to-whole ratio. Patrick, what do you think a part-to-whole ratio is going to be?
There's 4 little beads, and then there's 7 big beads.
You got it. Nice job. We have 4 small beads to 7 total beads. Those 7 total beads include the 4 small beads. So we could have 4, 7, or 3 to 7. Okay. As I'm walking around, I'm not sure, maybe you don't know where we are, what we're doing. But in your guided notes, you should be drawing these models on here at the bottom. Right? The part-to-part should be 4 small beads, colon, 3 small beads, or vice versa. I don't want you to just write 3 to 4 or 4 to 3 because you don't know what that means. Okay? You don't know that it's a part-to-part. Or it's a part-to-whole. Yeah. Then in part-to-whole, you should take the small beads and all the beads. You should draw that model. I'll explain. Right, and what do you think a whole to a part ratio is? Sydney. Good. 7 to 3. What does 7 to 3 represent? You're right with the ratio, but what is 7 to 3? Good. So whole to part is all of the beads, 7 to the 4 small beads, or all the beads to the 3 big beads. So part to whole and whole to part are the same. It's just the order that you put them is switched. Remember, order in ratios is really important. Any questions on those different types of ratios? Those are the only 3 that you can have. All right, what you're going to do then is you are going to move your partner. I'll let your partner sitting next to you. I'll share what you're going to go with. But what you're doing is, one, you're going to choose a part-to-part, part-to-whole, or whole-to-part ratio. Then you are going to come up with a real-life example for that ratio. An example would be, I'm going to come up with a part-to-part ratio. My part-to-part ratio is the number of boys to number of girls in this classroom. You cannot use that one because that would be boring. So just gave it to you. Be creative. Try to come up with something. Does everyone understand what they're doing? Okay, Lauren and Jacob, you two are working together. And Emma, you two are working together. You three will work together. And then Tom. What else you join? Brogan. Okay, you have 3 minutes to come up with this. Please write it down because we're going to share with the whole class. Clayton.
The football team has 4 losses and 7 wins.
Okay, 4 losses to 7 wins. I want you to put a 1 up if you think it's a part to part. I want you to put a 2 up if it's a part to whole. And then I want you to put up a 3 if you think it's a whole to part. 7 losses or 4 losses to 7 wins. Good. You should have a 1 up. That is a part to part, comparing your wins to your losses. Brogan.
So we did 5 small spiders to 11 spiders altogether.
5 small spiders
That's how
to 11 total spiders. What type is it? 1, 2, or 3? 1 is part to part. 2 is part to whole. 3 is whole to part. Good. We should have a 2 up. Small spiders to total spiders. Are those small spiders included in the total spiders? Yes. What makes it a whole? Whose is darker? All right.
We have 7 dogs and 5 cats.
7 dogs to 5 cats. Show me your number. Should be a 1. Okay, hard part. Dogs, cats, separate. Jason.
We did 27 animals to 7 monkeys.
Hey, which one? What's your number? 27 animals to 7 monkeys. Awesome. That should be a 3. You are comparing all of the animals to just the 7 monkeys. Are those 7 monkeys included in all the animals? Yes. All right. Josh.
There's 4 packs of chicken nuggets in the lunchroom and 2 packs of pretzels in the lunchroom.
Chicken nuggets. Are they dino nuggets?
That's what I said.
Yeah.
Oh. All right. So, what do we think? 1, 2, or 3? Awesome. It should be a 1. That's a part to a part. Sydney.
5 starters to 10 total.
5 starters, 10 people on the team. What do you think? All right, that should be a 2 part to whole. You have 5 starters, 10 people on the team. Those 5 starters are included in that 10. Hudson.
So 5 game consoles and 3 games.
5 game consoles and 3 games. Should be part to part. That's a 1. 2 separate things. That- Okay, 14 to 3. Packers to Chiefs. What do you think? That would be a part to part. Okay, you're comparing 2 separate things. Packers score to the Chiefs score. If you took Packers score to the total amount of points scored, that's a part to whole. All right. You take your shirt off so you wear your jacket. Yeah. Did you take it off after I said it? Fred. 50 games. All right. 8 wins out of 50. What type? That is a part to a whole. Nice job. Part to a whole. Then, Max?
So we did one building in Springboro, 6 buildings in Springboro.
One building in Springboro. What type of building? One school. Okay, so SI to all school buildings? Is that what you're comparing? That would be a part to a whole. Our SI is included in all 6. Jacob.
24 bars to 69.
Okay. Regular to big. Okay, that would be regular to big would be part to part. Okay. All right. Nice job. Let's go ahead and we can turn it over to the back. Part 3. The table shows the results of the 6th grade election for class president. You can write different ratios to describe their election results. There's a lot of them that you can write here. Okay? But the results are Devin has 20 votes, Jordan had 10 votes, and Micah had 5. You have these different scenarios for ratios. They are on your guided notes. The table is in your guided notes. You really don't look at the screen if you don't want to. I want you to go through A through E and determine true. You're going to write true if it's a correct ratio for this situation. If it is false, I want you to put false and then write the correct ratio. So make your false statement a true statement. If it's true, put true. If it's false, put false and write the correct ratio. Okay, the first one says the ratio of votes for Jordan to total votes is 10 to 35. Brayden, what do you think? True. Do we agree with true? Yes, I agree. The ratio of votes for Devin to votes of Jordan is 10 to 20. Lily?
False.
False?
It would be 20 to 10.
Okay, why is it 20 to 10? Brogan?
Because in the statement it says the ratio is Devin to Jordan, but in the ratio they put, it says Jordan to Devin.
Perfect. Order matters. Okay. What about C? Ella?
False.
False.
It should be 5 and 35.
Good. 5 to 35. That 5 needs to be included in the total. Okay, because that is a part to whole ratio. What about D? Jacob?
False.
False. Okay. Why is it false?
Because Devin's votes are 20 and Micah's is 5.
Okay. And why is it false? So you got to do it in the order, right? What comes first is Devin. Devin had 20 votes. Is 20 first? Yes. Okay. Then we have Micah. How many votes did he have? 5. That needs to come second. So is D true or false? Okay. It should be true. Oops. What about E? The ratio of total votes to votes of Devin. Hudson. True. True. All right, nice job. Is it true? It's not going in there. There we go. Okay. Questions on that? Okay, go ahead and answer the last question. Then see if you can compare 3 numbers. How would you do that? Try. What would you come up with? Okay, so write the ratio of the number of students wearing sneakers to the total number of students. Rylan, what'd you get?
15,
Okay, what type of ratio is that? Brogan. Part to whole. How would we write a comparison of three numbers? Tyson, what do you think? You can use the word 2, but most commonly you're going to see the colons. Good? Any questions from 10.1? Because we're about to move on. All right, you can go ahead and put the 10.1 guiding notes away. On that 10.1 notes, part 1, it says, the table shows the number of students who play each instrument in the school band. Write each ratio 3 ways. We don't need to write it 3 ways. Just write it as a fraction. Okay. Raise your hand if you play the flute in the band here at Spring Grove. No flutists? No. What about a saxophone? Raise your hand for the trumpet. Awesome. 3 of you. What about drums? Awesome. Raise your hand if you're in choir. What about strings? Nice. It's always interesting to know what you want. A. Write the number of students who play a saxophone to the number of students who play the drums as a fraction. Then that goes right here on your guided notes, that first line. And the second one goes the number of students who play the flute to the number of students in the band. Go ahead and write your fraction there. A, the number of students who play the saxophone, the number of people or students who play the drums. What would the ratio be as a fraction? Ella? 13 over 10. What type of fraction is 13 over 10? Tom? Improper fraction. You can change improper fractions to mixed numbers, 1 and 3/10. I don't want you to change them into a mixed number unless it tells you to. Okay, it's really hard to identify the ratio as a mixed number. Okay, so just keep it as mixed or as an improper fraction, and it's okay to have an improper fraction. B, the number of students who play the flute to the total number of students in the band. Clayton. 27 over 59. We agree? We get that 59 by adding all of these up. Go ahead and solve the next question. That is, a school baseball team has 5 pitchers, 2 catchers, and 12 other fielders. Right? Ratio to the number of pitchers to the number of players and number of players with plus. Alright, what is the numerator? Rylan? 5. That's the top number. What is the denominator? Tyson? 19. Okay, perfect. Okay, last question for this front page is, you don't have to write this down on your paper if you don't want to, I just want you to talk to your neighbor. Suppose you have a fruit box in which the ratio of the number of pears to the number of apples is 2/3. Explain what the ratio tells you about the relationship between the type of fruit in the box. So it's just talk to each other about what that means. Go. Alright, what does 2/3 mean? Josh? Good, it means there's going to be 2 pears and 3 apples in that fruit basket or box. Alright, you go with that?
Yeah.
Awesome. Now, something that you've done before that I'm sure you love doing. Okay? Key concept. It says equivalent ratios written as fractions and also can also be referred to as equivalent fractions. So who remembers doing equivalent fractions in 5th grade? Did you spend a lot of time doing them? Probably so. If not, in 4th grade as well. Okay? So a lot of time spent on them, so hopefully we have a good understanding. Equivalent ratios mean they have the same value, different numbers. Turn your paper over. Okay, see if you can write two equivalent ratios to 10/25. You may talk with your partner, come up with two equivalent ratios. You write it in the spaces provided. Okay, so let's talk about equivalent ratios. The ratio given to us, or the fraction, is 10/25. What is an equivalent ratio that is greater than 10/25? Becca. 20/50. What is less, smaller than, less than? Hudson?
2/5.
2/5. Okay. Is 20/50ths, 2/5, and 10/25 all equivalent to each other? Yes, they are. How do you know if two fractions are equivalent to each other? How you know that is if they have the same simplest form, they will be equivalent to each other. So you always take a fraction, bring it to its simplest form, then compare it to other fractions. If I had 10/25ths, how did I get from 10/25ths to 20/50ths? What did you do? Lily?
I multiplied both the numerator and the denominator by 2.
Perfect. Multiply by 2, multiply by 2. When you do this, you didn't multiply by 2, you multiplied by 2/2. What is 2/2 equivalent to, Ben? Equivalent to 1. If you take any number, multiply it by 1, you get the same answer. Okay, that's why 10/25ths is equivalent to 20/50ths. Because you multiplied it by 1. 2/2. What did you do to get 2/5? Rogan? Divided by 5/5. There you go. Which is the same thing as 1. Any number divided by 1 gives you the same answer. You take your calculators quick, and you take 10 fractions. This is a division problem. 10 divided by 25. What do you get? What's 20 divided by 5? What's 2 divided by 5? They should all be the same answer. If they are equivalent. What do they all equal? Tyson? They should all equal 0 and 4/10. We know that they are equivalent to each other. All right, calculators down. Eyes up here. Is there a certain amount of equivalent fractions that are going to be greater? How many can we come up with? Rylan? Infinity, right? We multiply by 2, multiply by 3, multiply by 4, 5, 6, 7. On forever and ever. Is there a certain amount that you can have that are less than? Yes, there is a certain amount. Okay? Alright, on your guided notes then, go ahead and circle which ratios are equivalent to 30/45. Hint to you, if you put them in simplest form, and they have the same simplest form, they are equivalent. Due to time, we gotta rush through this. But 30/45, which ones are equivalent? What do you think? Rylan? 6/9. Tyson. 35/50. What's 35/50 in simplest form? We can divide a 5 out. We should get 7/10. Is that equivalent to 6/9? Is that equivalent to 30/45? This one is not equivalent. Simplest form is 7/10. Simplest form here is what? Josh? 2/3. What about 100 over 150? Patrick? What did you divide to make it equivalent? You could divide a 50 out. Okay? 100 divided by 50 is 2. 150 divided by 50 is 3. What about this one? Simplest form would be dividing out a 3. So Jacob? No, I'm not a 3. Divide a 7 out. Yeah, PV equivalent. Divide a 7 out. And 3/2? Nope. Okay. Last thing before we go. There's something really cool you can use with the equivalent fractions on a multiplication table. If I give you the ratio 15/40, what's an equivalent ratio? 12/32. 6/16. Or simplest form, 3/8. 3 times 2 gives us 6. 8 times 2 gives us 16. 3 times 12 is 4. 8 times 4 is 32. See how you can use a multiplication chart for that? One more, last question. 48/72. What's an equivalent expression? Any of them? Less than or greater than? I don't care. Tom? 60 and 90 would be equivalent because they both have the simplest form of 6/9, which is in any, that's any simplest form, but that's what it comes to. Okay? Do the best you can on your 10-4 homework tonight.
14/21 too.